Good day, my name is Reza Affiq bin Ruslan, matrix number 2019728667, and I'll be presenting on my research project. The title of the study is Comparison between different types of foot arches in relation to speed among Malaysia women's field hockey athletes. Background of study. Running performance is influenced by many components including the initial strategy, step length, step frequency, biomechanics, neural influences, and muscle composition. However, there are some studies that prove the types of foot arches of runners can actually affect running speed. Most studies have found that athletes with high outfoot have better running speed when compared to low and normal outfoot. Target population was among Malaysian women's field hockey athletes. They are consistently involved in strenuous physical activities which requires them to have top-notch speed and agility. Statement of problem. There is limited research documented on foot biomechanics in correlation with running speed, especially foot out high. Furthermore, the relationship between types of foot arches and speed component involving Malaysian has not been established. Hence, it becomes the need for present study. From the evidence shown, this study is trying to prove which type of foot arch gives better result by highlighting the relationship between types of foot arches and running speed of Malaysian women's field hockey athletes. Research objectives. R1 or research objective number 1 to determine the type of foot arches of Malaysian women's field hockey athletes. R2 to determine the running speed of Malaysian women's field hockey athletes. And R3 to compare different types of foot arches in relation to speed among Malaysian women's field hockey athletes. Significance of study. Findings from the study should be able to help coaches to identify their athletes. Hence, will be able to give solutions according to returning performances of athletes. Knowledge could be given to runners and sports practitioners on how their types of foot arches are related to speed performance. Findings from the study should be useful for other researchers. We move on to literature review. Studies have been made on the foot arches and the effects on functions of lower extremity. Razgi, Bart, 2002 believe that the function of the foot depends on the shape of the foot to a significant extent. Sudhakar, 2018 stated that the foot is classified into 3 following categories depending on arch height. There are pes rectus, pes planus, and pes cavus, which is categorized into 3 using the morphology of medial arc. In addition, Williams, 2001 stated that runners with high and low arch feet with their different body structures might exhibit very different lower extremity mechanics. To explain the relationship between type of foot arches and speed, there is sufficient evidence from previous studies to prove that runners with high outfoot have better running speed when compared to low and neutral outfoot. A specific tendency can be known, namely, a high and normal arc type foot has a faster forefoot contact than low arc type if comparisons are made between the foot types. Maurice concluded that the high arc foot type was more beneficial for short distance runners. Next is methodology. Research design. The descriptive causal comparative research design was used in the study. Research questions and hypotheses of the study has been taken into account in selecting the design of this research. The rationale of selection is because the information needed for the study is obtained from a sample that represents population, which in this case, Malaysia women's field hockey athletes. Causal comparative design will be used as the study seeks to compare the independent variable of the type of foot arches and investigate the difference in running speed, which is the dependent variable that exists in between different groups of high, medium, and low outfoot. The result from the study was analyzed from one-shot data collection to control extraneous variables. Sample size. The number of population is known with a total of 30 athletes from multiple playing positions in the Malaysia women's field hockey team. However, 5 of the athletes were removed from the list as they were quarantined and were not present in the training camp during the test period. The study was then conducted on 23 national women's hockey athletes, as 2 subjects were removed due to inability to finish 30-meter sprint test due to injuries occurred in their training session. The total size of 33 samples were proceeded according to the availability of test subjects. Sampling technique. Perceived sampling of the non-probability was the sampling technique used to collect the samples from the sample size chosen, as they cannot be selected randomly. Samples with BMI in a predetermined range will be selected to limit generalizability. The BMI range should be in between 18.5 and 24.9 to maintain the reliability of test results. Moving on to instrumentation. The wet test was conducted to determine the types of food arches, which is the IV. First, water is poured into a tray that should cover and wet all parts of the food. Subjects then step into the water with one foot, then carefully remove their foot from the water. Next, they step onto a cardboard and place on a flat surface and put their weight on it. The food was removed from the cardboard and a photo of the footprint was taken for reference. The process is repeated with subjects at the feet. Figure 1 shows the procedures of the wet test. These are some of the results that we found from samples. As you can see, there are differences between high, normal, and low arc type. And this is the reference we use to determine the type of the full arc. 30-meter sprint test was conducted to determine speed. The test involved running at maximum speed over a distance of 30 meters with time recorded. Subjects performed similar warm-up. The starting point positioned at 0.3 meter behind the first gate. Subjects started from a stationary position. Subjects accelerate maximally to the finish line as fast as possible. 2 trials will be given and the best time was used. Figure 2 shows the 30-meter sprint test. The reliability of the test running surface and atmosphere of testing venue can eventually affect the results of the test. These conditions were recorded. We integrated timing gates to enable more accurate data to be collected, which enhanced the reliability of test results. Data collection procedure. Before starting any test, informed consent were distributed and filled by every participant. PAQ or Pre-Activity Readiness Questionnaire were used as screening to verify participants in good health and free from injuries, especially lower limbs. Their BMI were measured and recorded to make sure that they are in a predetermined range. The type of foot arc was measured using the wet test. After the foot arc was measured, subjects performed a 30-meter sprint test. The shortest time will be used. The data collected were arranged according to subject's type of foot arc and then analyzed to identify which type of foot arc shows better results in terms of speed. Data analysis. IBM SPSS 26 was used to analyze the data. Descriptive analysis was carried out using the mean plus minus SD. Inferential statistics were conducted to see the difference between the groups of high arc, normal arc, and low arc food. Analysis of variance ANOVA was conducted for the data distribution of 3 groups were found to be normal. Statistical significance difference was set at alpha p less than 0.05 with alpha equals to 0.05. Now let's take a look at the results. Normality distribution. An early analysis was conducted to determine the normality of data distribution. The normality of data was determined through the significant value of Shapiro wheel as the total data collected were only 23. Gupta, 2019, stated that Shapiro wheel test is a more appropriate method for small sample sizes, or samples of 50 and less. Data can be considered as normally distributed if the significant value of Shapiro wheel is more than 0.05. Table 1.1 represented the normal distribution results for all variables. Recorded results of Shapiro wheel are more than 0.05 on all groups. Therefore, the data from the study were assumed to be normally distributed. Next is descriptive analysis. The study was conducted on 23 national women's hockey athletes. Each subject was required to fill the demographic segmentation of age and playing position, and the data had been analyzed. Based on descriptive statistic table 1.2, the mean age of the subject is 22 plus minus 1. The subject's age range in between 18 to 35 years old. All subjects were female. Also shown in the table, the mean speed or time recorded in seconds, was 4.70 plus minus 1.63 seconds. With the fastest time recorded was 4.42 seconds, and slowest was 5.03 seconds. The mean BMI was 21.60 plus minus 5.0, with all of the subjects being in a predetermined range of 18.5 to 24.9 to maintain the reliability of test results. For the type of full up, 4 of the subjects possess high up, 15 of them are normal, while 4 others possess low up. Inferential analysis. As the data were declared as normally distributed, the parametric test of analysis of variance, or ANOVA, was conducted to compare the time taken for 30-meter sprint in between 3 groups of high, normal, and low up to determine which type of foot up shows better results in terms of speed. The result of the test revealed that p-value greater than 0.05 with p-value equals to 0.912. Thus, the null hypothesis was failed to be rejected. Therefore, it was concluded that there is no significant difference of running speed between the 3 groups of foot archers. Discussions. Comparison between different types of foot archers in relation to speed among Malaysia women's field hockey athletes. Findings from previous studies have led to the hypothesis made for this study. Based on the outcome of this study, it was concluded that there is no significant difference between athletes who possess high, normal, and low up on running speed. Hence, which type of foot up shows better results in terms of speed could not be determined. The results might be caused by the uneven distribution of data in each group, and also the small size of samples might be one of the reasons that we could not receive the expected outcome. Even though it is shown that the type of foot up may be related to running speed, other key factors that could possibly influence the result had been considered. This includes the running mechanics, muscle compositions, neural influences, track, and environmental conditions. Muscular power plays an important role in determining the speed of an individual. The correlations between concentric power and sprinting have been found in previous study of YB Young 2002. In addition, McBride 2002 stated that the effect of training power has resulted in improved sprinting time. Although subjects' BMI was set in a predetermined range to limit generalizability of test results, muscular power of athletes, especially their lower limbs, are different from each other. Other than that, the type of footwear used by athletes during tests could also be a factor of the test outcome. The type of footwear has some effect on speed of runner. Most of the athletes were wearing hockey turf shoes as the test was conducted on hockey turf. Most turf shoes are not made for a specific type of foot up, as running shoes do. Holoka 2018 stated that wearing unsuitable shoes for a specific up could result in stiffness, which would probably affect running speed. The difference in heights of the athletes could also be a factor as the stride length during sprinting affect running speed. This is strengthened by Numela 2007 that defines running speed as the product of cadence and stride length. In addition, field hockey athletes were used to train and run in constrained conditions of bowing low and holding sticks that might have adapted their running mechanics even without constraints. Widowski 2013 found that there are differences for the hip angular velocity between constrained and free running profiles during sprints. Despite all these factors, it can be seen from the raw data that some athletes can run faster even with low up, and some others run slower despite having higher up-high index. To conclude this study, it was found that there is no significant difference between high, normal, and low arches in relation to speed. Even though previous study have concluded it differently, the outcome from this study was not able to prove it. Other key factors that influence running speed might have affected the result. However, improvements could be made in the future to see different findings. Recommendations. To improve the clarity of results in future studies, it is suggested that the researcher collect more data from bigger sample size to prove that there is significant difference between the types of foot arches and speed. Number of subjects in each group could be even up to control the normality of test results. It is important to make sure that subjects are wearing suitable shoes during spin tests to make sure the results are unvaried. This includes the use of specific insoles for low-out runner to make sure the footwear used are uniform. The use of BIA or bioelectrical impedance analysis could be helpful to further limit generalizability of test results. Perhaps, future researchers could integrate specific equipment constraints to replicate the mechanical demands of a specific sport. That is all. Thank you for your time. Feel free to ask. I'll be happy to answer to your questions.